Functional groups are used in organic chemistry in order to show some reactivity or some functionality of a molecule. So we're going to start with our alkenes and alkanes. So an alkene is a hydrocarbon similar to an alkane, but here an alkene has a double bond. We show a double bond with a skeletal formula like this. It kind of looks like an equal sign somewhere on our zigzag. And what it shows us is that we have sp2 hybridized carbons. We'll review hybridization in the next module, but what it shows us is we have this double bond. So we have fewer hydrogen atoms than an alkane. Now there are still carbons at every end and bend. So this particular molecule here, we have 4 carbon atoms. So this is a C4, but how many hydrogen atoms do we have? Remember, the rules still hold. Carbon wants 4 bonds. So at each of these ends, we have methyl groups. So that's a CH3 on each of these ends. But what about right here? Well, we show 3 bonds. That means each of these is a CH. The H's, again, are implied, and we have to be able to count how many bonds we see in order to figure out how many H's we have. So here, this is C4H8. Now we'll go into alkenes with, relatively in depth later on in the course, but alkenes have a generic or a general formula of CnH2n. Remember, alkanes were CnH2n plus 2. Adding that pi bond removes 2 hydrogen bonds. So this is an alkene. An alkene is a double bond. That double bond does impart some reactivity, so we're going to start with our pi bonds as our first type of functional group. So we name an alkene by naming it as if it were an alkane. So if this was an alkane, this would be butane. But because we have that double bond, we have to change the ending. So I take the ane ending and I replace it with an ene. So this is butene. But it's not enough to just call it butene. We have to say where we have that functional group. And it doesn't matter on this particular molecule which way I number my chain, because the double bond will start at carbon 2. So this is called 2-butene. Now, you do need to decrease the numbering on your molecule if you have something where it does matter. So let's say I have something like this, and I have my double bond. Well, I have my double bond here. Then I do need to start numbering. I'm going to number from on the top here. So it's a 6-carbon chain, so this would be named hexane. But because we have that double bond, this is a hexene. And we started at carbon 2, so it's 2-hexene. We can't number it from the right, because numbering it from the right would make it 4-hexene, and that doesn't make sense. We need to decrease the numbers if at all possible. Now, if you have more than one double bond, see if I can clean this up a little bit. If you have more than one double bond, let's put another one here. Then we have what is called a diene. So we take that ane ending and we add diene instead. Now you do need to give an address for each of those pi bonds. So this would be 2,4-hexadiene. Now we also have what are called alkynes. Like an alkane, it is a hydrocarbon, but it has a triple bond. Now specifically, and I did this incorrectly, a triple bond, when you're looking at it with with this skeletal structure, we draw it linearly like this. So this particular molecule has 6 carbons to it. Remember, there's a carbon at every end and bend, but look right here. On either side of this triple bond, we have carbons. Now this triple bond locks those carbons into a linear formation and linear geometry, so that's just the way it is. So you have to recognize that there are carbons there. So when we go to name this, start with your alkane. So this would be hexane, but we need to change that A into a Y. So you change the ane ending into -ine, and then you give an address for that functional group. So this is a 3-hexyne. So now we're going to start looking at functional groups that have heteroatoms. Remember, in organic chemistry, a heteroatom is anything that's different than a carbon and a hydrogen. So we're going to start with what are called alkyl halides. Now, an alkyl group, remember, is an alkane that has lost a hydrogen somewhere, so it's going to bond with something else. That's an alkyl. And a halide is a halogen that is bonded to something else. So an alkyl halide is like an alkane that has a halogen to it. Remember your halogens on your periodic table. Periodic table looks like this. These are my noble gases. Halogens are here: fluorine, chlorine, bromine, iodine. Those are our halogens. So when we have an alkyl halide, and this is going to be interesting, or it's going to be important for chapters, I want to say, or modules 4 and 5 are where we're going to react them. The generic form of an alkyl halide, we say it's RX. R is the symbol for an alkyl group, and X is a generic symbol for a halide or halogen. Now, when we have an alkyl halide, we'll start with something simple, something like this. We would name this as either chloromethane, and that's what's called the IUPAC name. IUPAC name is the standardized name, or we could use what's called a common name. Not everything has a common name, some things do, but the common name for this would be to name the alkyl group methyl and then put chloride on the end. So chloromethane would be IUPAC, methyl chloride would be common. Now we could also have, say, something like this. Name the alkane first. Here we have propane. Number for your substituent, just like when we had alkyl groups as substituents. And we have a bromo group at carbon 2. So this would be 2-bromopropane. That is the IUPAC name. Now the common name would be isopropyl bromide. Again, that is the common name. So these are some alkyl halides, and like our carbons and our hydrogens, the alkyl halides can have an order to them. And when I say an order, I don't mean who comes first, but primary, secondary, tertiary. This is a secondary alkyl halide, and the reason for that is this carbon here is bonded to 2 other carbons. So because this is a secondary carbon that this bromine is bonded to, that is a secondary alkyl halide. Conversely, if we had something like this is a primary alkyl halide. This is called a methyl halide. And we can have a tertiary halide. Ooh, let's put an iodine there. So a tertiary alkyl halide, primary, secondary, tertiary, so that covers our alkyl halides. Then, moving on, we'll talk about alcohol. An alcohol group is a covalently bonded OH group. Now, in general chemistry, when you see an OH, usually we call that hydroxide. When it is an ion, it is hydroxide. When it is covalently bonded, it is an alcohol. So there is a difference. If you're asked, what is this functional group? This is an alcohol. It is not a hydroxide. Remember, in our group is an alkyl group. The OH group bonded to it is an alcohol group. When you name an alcohol, you will name the alkane. So this would be propane. See my 1, 2, 3 carbons. So that would be propane. But instead of that E, we're going to erase the E and we're going to put an OL ending. OL signifies that it is an alcohol. So this is propanol, but it's not enough to just call it propanol. We have to say where that alcohol group is, and it is on carbon 1. So this is a 1-propanol, and that is the IUPAC name. Now, if we had something like this, again, we have propanol, but now we have 2-propanol. Again, this is the IUPAC name. Now, the common name for this would be isopropyl alcohol. You may also see it as isopropanol. but the one with the number is the IUPAC name. That's how you can keep them separate. And the isopropyl alcohol, you were supposed to buy that in order to complete your lab kit. So those are our alcohols. Now, an alcohol can also have an order associated with it, primary, secondary, and tertiary. And I just erased it. So this is a primary alcohol. This is a secondary alcohol, and that is denoted by the carbon, the order of the carbon the alcohol group is attached to. This is a tertiary alcohol. So you see our alcohol groups, our alkyl halides, and our carbons, and our hydrogens are all ordered in approximately the same way. Then we have what are called ether groups. An ether group starts with an oxygen, and it has an alkyl group on either side, bonded to either side. Remember, an oxygen wants to make 2 bonds. So this would be the generic ether. So we have an R for our alkyl group, and we have an R prime, showing that it doesn't necessarily have to be the same alkyl group on either side of the ether. So when we have an ether, we show it like this. It takes the place of one of the carbons in our zigzag skeletal form. And when we go to name an ether, we name each of the arms and then put them in alphabetical order and add ether to the end. And that is actually the common name. So you can start there. So we have a methyl group and we have an ethyl group. So like before, it goes in alphabetical order. So we would call this ethyl, methyl, ether. Now the IUPAC designation, however, always wants you to find the longest carbon chain that contains the functional group. We're going to look at this as as a substituent. That is its own group. So we have 2 carbons here. So this would be ethane. And on carbon number 1, we have this substituent, and this substituent is called a methoxy group. So we have what is called methoxyethane. Now, if that particular arm of the ether was longer, then 3, 4, 5, then we would have to say where it was. So this would be 1-methoxypentane, because that would be very different than, say, 2, 3, 4, 5, 3-methoxypentane. So you do have to give that methoxy an address once you start getting into any chains longer than 2 carbons. Next, we have what are called amines. An amine is based on ammonia. This is ammonia. But if we take one of those hydrogens away and make it an alkyl group, then we have an amine, and this is specifically a primary amine. Now, amines have orders, but they don't necessarily, it's not what's the order of the carbon it's attached to, it's how many alkyl groups are attached. So a primary amine has 1 alkyl group, where a secondary amine will have 2, and a tertiary amine will have 3. And we can even have a quaternary amine. The quaternary amine will have a positive charge, but nitrogen can handle it. When we have an amine, maybe something like this. This is a primary amine. This, for the IUPAC rules, we would find our longest carbon chain that contains our substituent. In this case, our substituent is the functional group. And we would call this would be ethane because it's 2 carbons long. So we would call this ethanamine. Oops, I lost a letter there. Ethanamine. So you take the alkane name, take the E off, and add amine. This is the IUPAC name. Now the common name for this, we would have the alkyl group name, ethyl, and then amine. So another example here, if we have something like this, The IUPAC name uses numbers. So we would number the longest carbon chain that contains the substituent. In this case, the functional group is the substituent. And this would be 2-aminobutane. Now you may also see this as 2-butanamine or sec-butylamine. So this is the IUPAC name I would be looking for. However, you do need to know that all three of these names mean the same thing. This would be the common name that I would expect to see, and this would be the IUPAC name. However, I don't know where you're going or where you've come from. You may see amino used as a prefix instead of a suffix, depending on the rules of your particular major of study. So now we're going to move into functional groups that have a carbonyl. A carbonyl group is an sp2 hybridized carbon that is double bonded to an oxygen. This part is called the carbonyl. So a carbonyl carbon has some very specific reactivity that we'll talk about in depth in Organic 2. So we're going to start with the easy one. If I put an H over here, and it doesn't matter what's over here, we're going to call it a random alkyl group. This is called an aldehyde. Now an aldehyde group is called a terminal functional group. So an aldehyde group will always be at the end. When looking at the skeletal structure, it looks like this. Remember, the H's are implied. So this aldehyde group would be defined as carbon 1. So this would be called, using IUPAC names, we would name this as butane if it was an alkane. So we start with our butane. We're going to erase that E and add the ending Al. So Al is the ending for an aldehyde. Remember, OL was for an alcohol, Al is for an aldehyde. Now, if we remove that H and we put a different alkyl group there, then what we have is called a ketone. A ketone is a carbonyl that's somewhere along the carbon chain. And we do need to decrease the numbering of this functional group. So if I number from this side, 1, 2, 3, 4, 5 carbons on this chain, if it was an alkane, this would be pentane, but it's not, it's a ketone. So I remove that E and I add the ending ONE. So this is pentanone, but it's not enough to just call it pentanone. I have to give an address for that ketone group. So this is 2-pentanone. Now you were asked to buy a ketone in order to complete your lab kit, and that ketone, the common name for that is acetone. So again, that is the common name. But the IUPAC name, remember, that uses numbers. So we would number the chain to find the longest carbon chain that contains our functional group, and that is propane. But it's not propane because we have that ketone group, so I drop the E, add the ending ONE, and then I need to say where it lives. So this is 2-propanone, and that's acetone. Now, if I replace one of those endings with an OH, what I have formed now, this is called a carboxylic acid. And as the name implies, this hydrogen here is fairly acidic, but we'll talk more about acidity in the next module. So the carboxylic acid group is also a terminal group, just like an aldehyde group. And it defines the end of the carbon chain. So we always number from one of our terminal groups. But name it as if it was an alkane. So here we have 4 carbons, so this would be butane. But because it's not butane, we have that functional group, we remove that E, and we're going to add the ending oic acid. So OIC acid is the ending for carboxylic acid. So this molecule would be called butanoic acid. And now a derivative of the carboxylic acid, if I take that H off and I replace it with an alkyl group, then we have what is called an ester. As an example of an ester, we could have something like this. To name an ester, you name each side of this oxygen. So here is a methyl group. And then this part here, how many carbons do we have? Well, we have 2, so that would be ethane if it was an alkane, but it's not. It has this functional group attached to it. So like the carboxylic acid, we would replace the E with an O, but this time we call it O8 instead of oic. So this would be called methyl ethanoate. And that's how you briefly name an ester. The last functional group we're going to look at is when we have a nitrogen in the alpha position next to that carbonyl. So the alpha position is the next door neighbor. So if this is my carbonyl carbon right next door, we have that nitrogen. So that is the alpha position. And this is called an amide. Sometimes people pronounce that I long and call it amide. Doesn't matter to me what you call it as long as you can recognize it. So this is an amide. I'm not going to ask you to name any amides, at least early in the class. But if you have something, if you have an alkyl group attached to the nitrogen, then you would name that group as N something. So if we had an N-methyl butanamide, then the but tells us we have 4 carbons. The amide tells us we have this kind of a group. The N-methyl tells us we have a methyl attached to that nitrogen. Now remember, hydrogens are usually implied. I'm going to put this one in just for convenience sake. So this would be N-methyl butanamide. So now let's work on recognizing some functional groups. So what we have here, this is tetracycline. So immediately we can find these OH groups. These OH groups are alcohol groups. Just going to highlight all of those OH groups. Now I also see that I have some double bonds. So these double bonds tell me that they are alkenes. And then over here I have a nitrogen. This nitrogen is attached to 3 hydrogen groups. So this is a tertiary amine. Tertiary amine. And I know it's tertiary because it has 3 bonds to carbons. And then down here I see an amide. So here's my carbonyl carbon with my nitrogen next door. That is a primary amide. And then I also see this one here. Well, that's awfully dark. This is a ketone. See how that's a carbonyl carbon with 2 alkyl groups, one on either side. So that's a ketone. And so is this. So that is what I expect you to do. I expect you to see where the heteroatoms and the pi bonds are and be able to pick out your functional groups. So now let's practice a little bit of naming. There is more naming in the classroom, but let's practice some naming with IUPAC rules. So remember, we need to find our longest carbon chain that contains our substituents and functional groups. And here I have 4 carbons. So I would name this butane if it was an alkane, but it's not. So let's look at our groups. We have an alcohol group. So that means my ending is OL. And then we have a methyl group, and they are both at carbon 2. So I'm going to remove that E from butane and put OL. And I would call this 2-butanol. Now, I would say recently IUPAC updated their rules, but you know, for me, 10 years ago was recently. So this could have been 10 years ago, where they started putting the number for the ending group inside the name. So you may see butan-2-all, see, old habits die hard, as the root name of, or the base name of this kind of a molecule. And that's okay. Either way works for me. So 2-methyl butan-2-all or 2-methyl 2-butanol. That's how you would name that one. Now here we have an aldehyde group, and I need to find my longest carbon chain. It's 5 carbons long, and I have an aldehyde group. So this would be pentane, except I don't have an alkane, I have an aldehyde. An aldehyde has an Al ending, so this is pentanal. I do not put a number with that ending because it is a terminal group. It's defined as being at the end, at the terminal carbon. Now I do have 2 methyl groups here, both on carbon 4, so I would call this 4,4-dimethyl pentanal. For C, we need to find the longest carbon chain. So I'm going to go straight down here. That's 6 carbons. But what if I went the other way? Would I also have 6 carbons? And the answer is yes. So it doesn't matter which leg you want to travel down. I'm just going to leave it like this. So I have 6 carbons. That means a hexane if it was an alkane. It's not. It's a ketone. So I put the O-N-E, own ending at the end, and I need to say where that is. Now this is another one where you could have the number inside. It's okay with me, whatever makes you happy. And then we need to talk about our substituent. Now our substituent is at carbon 4, and it is an ethyl group. So this would be 4-ethyl-2-hexanone, or 4-ethyl-hexan-2-one. For D, we have a carboxylic acid, and here we have to turn the corner with our numbering. We have to go up here so that we have a methyl group, and then we have our carboxylic acid group. Now the ending for a carboxylic acid group is oic acid. We have 5 carbons here, so this would be pentanoic acid. The carboxylic acid group is terminal, so it is at the end. Then I have to name my substituent. So it's 3-methyl pentanoic acid. I put this table here as the naming hierarchy for compounds that have more than one functional group for you to refer to. It's not something you need to memorize, but do be aware that this table exists. So it's in order from the bottom to the top of the least oxidized to the most oxidized. So the way that you use this table is you identify the functional groups in the compound first. You're going to name the longest carbon chain that includes those functional groups. The functional group that is highest or more towards the top on this list then gets the lowest number. It also gets the suffix. Then the other functional groups will be assigned the prefixes based on the number order that you assigned in the previous step. So the higher on this list, the more oxidized it is, then it gets to be this suffix. So for example, if we had a compound that had a carboxylic acid over here, and let's say it had an alcohol group here. Well, the carboxylic acid being at the top of the list, that means the name of the molecule will end with oic acid. We're going to number starting with the carboxylic acid, so this would be butanoic acid. And then we have this alcohol substituent. And the alcohol, it's right down here at the bottom. The prefix for an alcohol group is hydroxy. So this would be 3-hydroxybutanoic acid.